हेलो गाइस, आई होप यू पीपल ऑल आर डूइंग वेल। आई नो आज हम डिस्कस करेंगे एक नया टॉपिक दैट इज पॉलीमर केमिस्ट्री। आई डोंट थिंक दिस इज ऑफ ऑर्गेनिक पॉलीमर केमिस्ट्री व्हाट आई एम डीलिंग विद। इट इज अ फिजिकल पॉलीमर केमिस्ट्री. Okay, the reason why I selected this topic is, first of all, it is the easiest one. Okay, easiest one. Just a second, guys. Yeah, okay, easier one. Next thing is, within 2 to 3 classes, the whole polymer chemistry will get completed. And I'm not going in deep with it, how much it is required for the purpose of exam. That much only I'm telling you, I'm going to teach you. बाद में हम क्वेश्चंस डिस्कस करेंगे प्रीवियस ईयर में what all things they have asked. That much is well and enough for the upcoming exam. Okay, so yeah, within 2 to 3 classes the polymer chemistry will get completed. Let's and yeah, questions we can discuss it based on the formulas. Okay. Yeah, you may ask me, ma'am, it is physical ka part, only problems are enough, right? Why we need to go with the theory? Yes, theory for some extent it is also important because we may get direct questions on the theory part. So let's study some theory concepts also. Okay. Yeah. So let's start with the introduction itself. I know you people are well versed with this polymer word because you are studying it from first first PUC itself. Yes or no? Yeah. So polymer we can also call it as a, yes, we can also call it as a macromolecule. Keep in mind. Okay. So it is a macromolecule which is having high molecular weight. Okay. So it is a high molecular mass compound. High molecular high molecular mass compound. Okay, just start noting down things. Whatever I'm writing, that much is enough for you for the purpose of exam. Again and again I'm telling you guys. Okay, so high molecular mass compound, its mass may reside from 5,000 to 1 million. Okay, yes, macromolecule, high molecular mass compound. Can you give me one simple example for a polymer? Yeah, yes, it is what the polymer. Best example I can tell is a protein, है ना, which is made from the monomer called monomer amino acid. Okay, it is made from the monomer called amino acid. So what we can tell, polymers are nothing but which are made from the monomers, where several monomers connect each other to form a polymer. So polymer is formed when several monomers are combined. Okay, when several monomers are combined, we can get a polymer. The one more example we can tell, that is a polyethene, which is formed when several ethene molecules are combined. Okay, if I take you general example, like, let me write it here, later on we can erase, like a. Okay, let me take simple example, just a general way. If I take, so this is polymer, if I say, then A will be a monomer. Okay, A will be a monomer. Don't write this degree of polymerization now. Huh? I'm just explaining because I didn't got any space to write about. Okay? So A is a monomer which is connected repeatedly through a covalent bond. Okay, through a covalent bond. Through a covalent bond, and this monomer I can also call it as a repeating unit. Okay, it is a repeating unit because it is repeating again and again to form a polymer. Okay, so monomer is a repeating unit. which connects again and again, we will get a polymer. So polymer, which is formed through a monomer. This much it is clear? Yeah. Let me erase this. Okay. So next, let's go on to the degree of polymerization. If I want to tell in a simple way, what is degree of polymerization is a number of monomer unit present in a polymer. Okay. Yeah. Let me take again a general example, that is A. Okay. So yeah, n times it is repeating. Let me consider. No. Let me consider it not n times this much. Okay. Yeah. So this is a polymer. So how many monomer units are there present in this? There is one, two, three, four, five. Okay, five monomer units are present in this polymer. So degree of polymerization, it is 5 for this. Okay, and this degree of polymerization, it is denoted by P. Keep in mind. Okay, like that. So number of monomer units will be equal to the degree of polymerization. So there is a simple formula you can remember is P is equals to capital M divided by small m. What is this capital M? It is molar mass of, okay, molar mass of polymer. Molar mass of polymer. Next, this one, it is molar mass of monomer. Clear? If you people are knowing the molar mass of polymer and molar mass of monomer, you can calculate the degree of polymerization. Man lo, I have a protein molecule now. Its molar mass, it is 50. Okay. And one amino acid ka molar mass is around, yeah, 3. Okay, 3, let me consider. So let me divide it, 3 ones are 3, so to 16 point something. So its degree of polymerization is around 16, like that. Clear? Okay. So like that we can calculate. And again, now we are knowing degree of polymerization, it is around 8. Okay, let me consider 8. And I am knowing the molar mass of polymer, it is around 60. And I don't know the molar mass of monomer. So I can calculate like this also. Based on the question, we can calculate this. Clear? Acha. Now, let us go on to the classification. Okay. Based on the connection of the monomer in a polymer, we can calculate, we can classify the polymer into 2 types. Okay. Yeah. If it is of, okay, let me take a simple general example again, A connecting to A and so on like this. Okay. So if this is the type, if only one monomer unit is there, no problem with the connection. Okay. Always A will be connecting with the A only. Okay. So if the monomer is of the type AB, okay. If it is of the AB, there are, let me consider there are several monomer units like this now, AP, and so on like this. So in this case, there will be the problem with the connection. Okay. Let me tell this as alpha and tell this as beta. Okay. Or let me consider this as head and this as tail. Okay. I'm just considering. I can also consider this as tail or this as head, like that. Okay. Just for my convenience, I'm considering this as head and this as tail. Clear? Yeah. So connection will be of 2 types here. Like A, B, okay, this is one monomer unit. This B can either connect to this E, A, or it can connect to this B. Yes or no? So let me consider this. B is connecting to this A. Again, this is one monomer, this is one monomer. Okay, this is alpha, this is beta. So this is alpha, this is beta. This B is connecting to AB again. This B is connecting to AB, like this and so on. Okay. So this is head, we consider alpha, this consider tail. Yes or no? This is head, this is tail, this is head, this is tail, like that. Okay. So this type of connection, I can tell it as a head to tail connection. Okay. Head to tail connection. Clear? Getting? Later on, I will explain you with the example, but just keep in mind what is this head to tail connection now. Okay. Next one is this type. Okay. So let me consider this monomer unit AB. Okay. This is alpha, this is beta, this is head, this is tail. If this B is again connected to this B, okay, next comes is A only. This is another monomer unit, okay. A is connecting to A itself, okay. So B is connecting to A like that, okay. So this is alpha, beta. So this is beta, alpha, alpha, beta, beta, alpha like that, okay. So this is tail, this is head. You know, alpha is head, this is tail. Okay? So this connection, if we see, this is tail to tail. This one it is head to head. So this example it is of the type head to head or tail to tail connection. Getting clear, everyone? Yes. So these are the two types of the classification based on the connection. Okay. Let me take one example. Like, let me take a monomer unit CH2 double bond CHR. Okay, this is a monomer unit. Let me see with the connection for head to tail. Let me take do the head to tail. Okay, so this is alpha, this is beta. So CH2, okay, CHR. Okay, so this is alpha, this is beta. So beta is connecting to alpha now. CH2, CHR. Okay, again CH2, CHR. Getting? So this can be the example for head to tail connection. Alpha, beta. Getting? Okay. So now just concentrate on the carbon atom I am marking. Okay. The carbon atom I am marking. So this carbon atom, is it not a asymmetric carbon you are feeling? है ना? Chiral carbon, optically active carbon, the carbon which is attached to four different groups, which is attached to four different groups. Yes or no? So this carbon, based on this configuration of this carbon atoms, we will again classify into the different types. Like this carbon configuration, if it is a chiral carbon, if it is a asymmetric carbon, it can be either D or L. Yes or no? This again, it can be either D or L. This one, it can be either D or L. Getting? So based on the configuration of the asymmetric carbon in a polymer, we can classify into different types. Okay, let me study that. Okay, classification based on the configuration of the asymmetric carbon of the polymer. Okay, let me take the same example itself. So, yeah, yeah, I will take yellow, dirty fellow. Okay, so yeah, let me define this first. All the asymmetric carbon, if the asymmetric carbon, okay, if asymmetric carbon, if asymmetric carbon has, if all asymmetric carbon, okay, if all asymmetric carbon has same D or L configuration, okay, D or, sorry for the handwriting, huh, D or L configuration, then I say that polymer as a isotactic polymer. Okay. So let me write like this. Can you, if you people have studied stereochemistry, then this concept will be knowing for you. Otherwise, just keep in mind, just keep the definition and the thing in mind. That much is enough. Okay. So this is R and this is H. Okay. So here R is in the wedge side, right? Again, R will be in the wedge side. That is what. If this carbon atom is D and this, then this carbon atom will also be D. Okay. R. H, R, H, like that. Okay. So this will be D, D, and so on. Okay. All asymmetric carbon has same D or L configuration. So such polymer, we will call them as isotactic polymer. Okay. Next, let us move to the syndiotactic polymer. Okay. Syndiotactic polymer. So here, alternate D or L configuration is present. Okay. Alternate D or L configuration. Alternate D or L configuration. Like it is a polymer unit. So here it will be 1, 2, 3, 4, 5, 6, 7, 8. We know this 2, 4, 6, and 8, they are a symmetric carbon atom, है ना? So if this is D, okay, if this second carbon atom, if it is D, then this definitely it will be L configuration, okay? Alternate. If this is L, then let me write here like second one it is D, this is L, and this one it will be D. Okay, this one it will be D, and next this one it will be L, like that. Okay, so alternatively there will be the configuration. Clear? This is for the syndiotactic polymer. Next, let us move to the eutectic polymer. Here, random configuration will be there. Configuration will be random. Random configuration. Whatever I am telling, that much is enough, guys. No need to bother. If we start solving the problem, then we can complete polymer easily so that you can solve any of the questions asked in examination. Clear? Okay. So random configuration like this. So here, let me consider this one. It is whichever the configuration. Okay. So it can again be the same. It can again be the same. And it can be the different. It can be like this. Okay. Random configuration will be there in eutectic polymer. Now, this isotactic and syntactic polymers are said as, okay, let me consider this as 1 and 2. So, can write as 1 and 2 are called, 1 and 2 are called stereoregular polymer. Okay. Stereoregular polymer. Keep in mind, isotactic polymer and syntactic polymer are said as stereoregular polymer. And in the next class, I want what is this meaning of stereoregular polymer. Clear? Now, it was a very old, okay, around 1900, I hope so. I can't tell the exact uh, date, but to synthesize this isotactic and syntactic polymer, a catalyst was synthesized, okay? A catalyst was synthesized. Even now we are using the same catalyst to synthesize this isotactic and syntactic polymer. That catalyst is called as a very popular catalyst, guys. That is Ziegler-Natta catalyst. Okay, Ziegler-Natta catalyst was synthesized. You can write it is of titanium tetrachloride plus aluminium triethyl. Okay. So this Ziegler-Natta catalyst was synthesized to prepare this stereoregular polymer. They are isotactic and syntactic polymer. Clear? Let's move on to the next one. Types of types of average molar mass of the polymer. So before going with this, let me tell you one thing. Actually, this polymer, we know it will be the straight chain like this. Sorry. Yeah. Let me erase this completely. Okay. We know it will be like this straight chain, large molecular mass, macromolecule, है ना? So actually, most of the times they don't exist like this, okay? Because of this straight chain, they will be in the form of breakage. Okay, there will be the breaking thing, and small units will be arranged like this. Getting everyone right? So because of this reason, we can't calculate the accurate, okay, accurate molar mass of the polymer. Accurate molar mass of the polymer cannot be calculated. So we start calculating the average molar mass. Clear? So there are four types of average molar mass of the polymer. Let us study the first one, that is number average molar mass. Okay, let me erase this. Okay. So number average molar mass, it is denoted by Mn. Okay. Let me give you a formula first. Okay. Summation of Mi divided by summation of Ni. Okay. So yeah, can also elaborate it as where I will be from 1 to infinity. Okay. M1 N1 plus M2 N2 and so on divided by N1 plus N2 plus N3. Okay. So what is this Mi actually? Here, let me write here. Yeah, Mi. It is nothing but molar mass. Molar. A very important formula, guys. Okay. Just remember, most of the questions will be asked on this formula. Okay. Actually, from here, you may get maximum questions. Okay. From this topic. Molar mass of monomeric unit. Monomeric unit and Ni number of, okay, number of monomeric unit. Number of monomeric unit. Just write down monomeric unit. Okay. So let me explain you by taking one polymer. Okay. Yeah, this is polymer. Yeah. So one, two. These are the monomeric units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay. So I said now this one won't exist like this generally. So it will be in bracket form. Okay. 3, 4, 1, 2, 3, 4, 1, 2, 2. Yeah. Like this. Okay. So how it will be? 1, 2, 3, 4. This part I am taking. Next it is 1, 2, 3, 4. This part. Next it is, that is 9, 10. Next 11, 12. It is 13, 14, 15. Okay. So this, okay, this unit, its mass is 50. Like that, its mass will also be 50 because monomeric units are same. Here also 4, here 4. Okay. Its mass will be 20, sorry. Its mass will be 20 मान लो. Okay. So same because same monomeric units are there. Its mass मान लो it will be 30. Getting? So how many units are there whose mass is 50? There are two units whose mass is 50. Yes, plus how many units are there whose mass is 20? Two units are there whose mass is 20. Plus one unit is there whose mass is 30. Divided by 2 plus 2 plus 1. Okay, this is what it means exactly. Getting the concept? Yes. Yeah. So note down, guys, note down fastly. Let me erase this side ka part. Okay. Yeah. Okay. So one more thing is there in this case is the method of determination. Okay. Method of determination. A very important thing because they may ask straight away question which method is used for the determination number average molar mass. So you should be knowing, just write it in a bracket and put it as important, guys. We will use osmometry method, okay, for the determination of number average molar mass. Just let us go a little detail about this osmometry method, guys, because you may get a question on the based on the graph also. Okay, so the first thing, by seeing this word osmometry, we will get in our mind is osmosis, right? Osmosis. So what is this osmosis then? Yes, just imagine, guys, your mother is doing a mango pickle. What she do? She takes that mango and put it in a salt concentration initially. Okay, so let me do the same now. I am taking a salt concentration here and I am putting a mango pickle. Okay, mango pickle in a salt concentration. It is first day now. Okay, so day by day what happens, there is the mango starts shrinking, right? You know, might be knowing what is the meaning of shrinking, like mango starts shrinking like this. Then what might be the reason for the shrinking of the mango as the day passes, guys? Yes, there will be the movement of water molecule. Okay, movement of water molecule through from the mango to the salt concentration. है ना? There will be the movement of water molecule. Means I can tell this process is osmosis, where movement movement of solvent, है ना? Solvent. Water is a solvent, polar solvent. Movement of solvent through solution, through, not through. Okay, just there is this movement of solvent to solution. Okay, movement of solvent to solution. Okay, movement of solution, just make it solution. Solvent to solution is called as a osmosis. Means from high concentration to low concentration it is moving. Means so high solvent concentration to solution. Okay, so I can also explain you in this way. Let me take a beaker. Here semi-permeable membrane is placed. Here, can you tell me which is semi-permeable membrane in this case? Yes, this itself is a semi-permeable membrane. Okay, semi-permeable membrane is there. Here it is a solvent. Okay, solvent, and here it is a solution. So movement is from solvent to solution. Okay. Now I just want to stop this flow. Okay, I just want to stop this flow of solvent to solution. So what will I do? I just put a piston here. Okay. इधर मैं एक piston डालती हूँ so that, and through that piston I just start putting pressure on a piston so that the flow will be stopped. Okay. Means why I'm putting pressure is to stop that flow of solvent to solution. That pressure I will call it as a osmotic pressure. Okay, osmotic pressure. हाँ. Okay, so yeah, so some pressure is applied. That pressure it is known as, let me denote it as pi. So that pressure it prevents the flow of solvent to the solution side. Okay, that is what the osmotic pressure. Okay, so yeah, so next, through ideal gas equation, let me consider, you people might be knowing what is the ideal gas equation, which is written as PV is equals to nRT, right? So can I write P is equals to N by VRT? Yeah. So what is this N by V? Actually, it is nothing but a concentration, you know, concentration. N is number of moles, mole per liter. It is concentration. Okay. Actually, na, this equation, it is, yeah, we will generally use this equation. Just a second, guys. So this pressure, let me write it as pi. Pi is equals to CRT, where pi is osmotic pressure. This is also pressure, this is also pressure. So just I am replacing this P by pi. Okay. This equation actually we will use like this only, but it is represented like pi is equals to CRT 1 plus BC1 and so on like this. Okay. This concentration we generally write it as number of mole per liter, right? Mole per liter, right? Mole per liter. Let me write like this, mole per liter. Okay. So, but here I am writing this concentration as gram per liter. Okay. But actually it is mole per liter. So just to make it this gram per liter as mole per liter, I just divide it by gram so that gram can cancel into per mole. If this per mole goes up, it will be mole like that. So what is this gram per mole then? It is nothing but a molar mass. Mass of one mole. Mass of one mole is molar mass. Yes or no? So keep in mind, guys, this concept. Okay, if the concentration they have given is in gram per mole, just divide it by molar mass, then we will get the exact concentration. Don't take the same value, okay, as a concentration. We need to divide it by m. Getting everyone clear? Acha. So let me erase this thing, guys. Okay. Yeah. So now pi is equals to, I'm taking C by M, RT 1 plus B, C1 by M, and so on like this. And this, can you tell me what's the unit of this concentration now? It will be definitely gram per mole. So that we are, that's why we are dividing it by M. Okay. So pi by C is equals to RT by M, 1 plus BC1 by M and so on. Okay. So just multiply RT by M plus RT BC1 by M square. Okay. Which is equals to pi by C. Just drawing a graph. Okay. That is pi by C versus C. Okay. So this is equal. Can I represent it as y is equals to mx plus c? Right, mx plus c, where c is nothing, x is nothing but, where x is nothing but this c. Okay, m is a slope here it is b rt by m square, this is a slope. Okay, in c is a intercept, that is rt by m. So it is a straight line graph where intercept is equals to rt by m. Okay, intercept is equals to rt by m. Okay, so this intercept actually it is nothing but RT by M. It is nothing but number average molar mass. Clear? Which is experimentally determined. Okay, so this much is important, guys. This value is important and this graph is important. This last equation, it is important. Keep in mind. Clear? Okay, let's go on to the next type now. That is mass average molar mass or weight average molar mass, which we denoted by m small m or m w like this. Okay. So you people are knowing what is number average molar mass, how we will write it is summation of Ni Mi divided by summation of Ni. Yes or no? Am I correct? So I will give you one hint to remember this m small m, which is equals to, just multiply this numerator and denominator by mi, you will get mi. Okay, that is mass average molar mass. Okay, so summation of ni mi square divided by summation of ni mi. Getting? Okay, so if you want to elaborate this, m1 square plus n2 m2 square and so on, it will be N1, M1 plus N2, M2 and so on. Okay. And the method of determination, very important guys, keep in mind the method of determination of mass average molar mass, it is light scattering method. Okay. Light scattering method. Light scattering method. Clear? Sure. So next it is Z average molar mass. Okay. Z average molar mass. Just write it like this. Now here, if we know this mm, then we can get this nz. Just and multiply and divide numerator and denominator by mi. Okay. So it is summation of ni mi cube divided by summation of ni mi square. Okay. So this is what Z average molar mass. If we want to elaborate it, mi, sorry guys. Okay. N1 M1 cube, N2 M2 cube, and so on. We will discuss the problems on this later. Okay. So N1 M1 square, N2 M2 square, and so on. Okay. So this is what Z average molar mass and the method of determination. No need to go in detail with the method of determination of this light scattering. And here it is sedimentation. Sedimentation. They will ask direct question on this. Just remember sedimentation process. Sedimentation process is the method of determination of Z average molar mass. This much is enough, guys. So the remaining thing we can study in the future classes. Yes. Thank you. Bye.